Good morning again. So I'm going to talk about Cloud-Enabled Security Services, or CESS. So this is one of the components in our AsiaConnect project. So let me start with security issues in network services. So one of the major issues we have is DNS attack. And if we further categorize, we have domain hijacking, and we also have cross-site scripting. So domain hijacking happens when somebody changes the domain addresses without the user knowing. So even though you are typing facebook.com, you are not actually going to facebook.com, you are going somewhere else. Similar thing is cross-site scripting as well. So you are trying to get service from one provider, but the service is actually coming from intruder in the middle. So these are one of the attacks we face in the network services. There is man in the middle attack. It happens if there is two cases. One is if the communication is not secured at all, and this also happens if you have weakness in the SSL layer. If SSL library is not updated, rudely built, so the man in the middle attack can happen. So what it means, between our communication, there is a man and there is an attacker in the middle who can control the communication between the sender and the receiver, right? So another type of attack we have, IP spoofing, which is highly used for DOS attacks or DDoS attacks. So these are, this is how they spoof that attacker spoof the IPs and try to overuse the services of a particular web server or network service, right? So IP spoofing is used because we cannot reach the valid senders in this case. There is also network sniffing. Sniffing means the network traffic will be monitored without the unauthorized parties, without knowing it, without you knowing it. In some cases, there is network monitoring that we saw in the first session, which could be valid or which could be invalid. Okay. So sniffing means the packet can be captured, the packet can be analyzed. So some of the things are necessary for protection. Some of the things can be used by the adversary for further attacks. Okay. So there is a fine line between what is authorized and what is unauthorized. So one of the solutions that is coming through recently is called CESS, or Security as a Service. So this is, the idea is we can provide the security as a service so that the end user do not have to build the infrastructure to provide the service or to make its system secure. Okay? So this is inspired by SaaS model, software as a service. Okay? So this is the same system, so we are getting some kind of service. Instead of software, we are getting service as security. So this is getting more and more popularity nowadays. So that we have centralized system which can provide us security in the cloud, and we do not have to, I would not say we do not have to, we still have to have end user security. But when you have something, then the infrastructure can be built in the cloud instead of in every institution or every businesses. So this doesn't require on-premise hardware as we see in the current models, and as we saw in the last day as well. When you move things to the cloud, the infrastructure costs become less, so it becomes cost-effective for the businesses and end users. So when you move things to the cloud, that means now we have control over the whole data, the whole data that is coming into the networks, not only the data that is coming to my company. So instead of securing my own system or my small network, we can try to secure the whole network as well. Okay? So that is one of the advantage point we have in CESS. So what kind of security service can actually provide? Okay? So we can categorize it into 6 broad areas. First one is Identity and Access Management, or IAM. I think one of the speakers talked about it yesterday. Intrusion Detection and Prevention, or IDP. We have SIEM, Security Information and Event Management, Web Content Filtering, Email Security, and Vulnerability Management. So these are the broad categories of services that can be provided from the cloud, okay, to the end users. So if you look at a little bit detail into each of it, so Identity and Access Management basically means you provide access control to the end users, how they're going to use the system. Not the cloud system itself, but also how they're going to use the services or the resources you have within your network. Okay? So if you look at some of the use cases, organization employees accessing SaaS, organizational SaaS, not your own particular SaaS. Like if you have like Google business data, business emails, business docs. So if you want to control those things, so that is, someone has to monitor those, someone has to control those access to the end users. So IAM can be used in those scenarios. So IT admin needs to provide, resources to the users so that they can do certain things. For example, if I relate it to the BDDAP, they provide services. They want to create virtual machines, create networks, provide access to the customers or users, right? So that means somebody has to do it. So who can do it? Those kind of access has to be provisioned into the system. So this kind of scenarios IAM can be used, and developers can create their partner accounts in the system. End users can use storage in the system. So whenever you provide some kind of access to any infrastructure that we have, then we need to use some kind of IAM mechanism. Okay? So this is one of the scenarios. So basically when you talk about IAM, we have user management, authentication, authorization, access. These are regular things that we have to provide to the end users. So when you talk about IAM, this kind of feature has to be built in there. Okay? So next thing is intrusion detection, or IDS. This is a very core feature of any security system. Whether this is end user, whether this is network services, it has to be there. Okay? So the idea is it can be a device or it can be a software that can monitor the network, and it can identify malicious activity, something unusual that is going on. Okay? So that is the basic scenario, as well as it can detect if there is any policy violations. Okay? So policy violations means, for example, you have your organization and you don't want people to use their personal email accounts. Okay? So that is one of the policy that you have. So it can be configured in the IDP mechanism so that you can control those things, that whether your policies are being enforced to the end users. Okay? So there are different methods we see in the actual literature, as well as in the research, also in the end market. There's signature-based mechanism, there is anomaly-based mechanism, there is also stateful protocol analysis. So most of the things that we see in the market, like antivirus softwares or internet security softwares, these are signature-based methods. So what it means, this system, they are detecting signatures of viruses, malwares, botnets, all those things, and they are basically matching the signatures whether this is a valid file or whether this is a virus, right? So this is the most method they use this feature. Anomaly, on the other hand, they have what is normal. They have certain static files, certain signatures, that is, they treat as a normal. Then they can, whatever that is, that doesn't fall into that paradigm, then they can take it as a abnormal or anomaly behavior. Okay? For example, in the first session we saw high uses of CPU RAM when there is an attack, right? So if you think the your normal behavior is, say, 20% of CPU uses or 30% of CPU uses. So when you see the CPU uses is 70%, 80%, that is an anomaly. That is basically what is happening. Okay, so this is, we are saying, okay, when this is an anomaly, that means we have to do something about it. Okay? So this is another type, and also stateful protocol means your system always has to be in certain state. Okay? In terms of data, how much data you are processing, how much data is coming into the system. So it's always in certain state. It should not jump. Okay? It should grow more linearly, okay? And it should also go down linearly. So when there is a burst, that means the state will change drastically. So these are the different algorithms are available there. So, these are integrated into the IDP system. So whenever we have an IDP system available, so what it tries to do, it tries to block this kind of attacks so that the end users are more secure. The third type of services that we can provide is called SIEM, Security Information and Event Management. This is two stages. This is more, I think, related to IT administrators or forensics. So the idea is whenever all the devices or softwares that are used in the network level or monitoring level, they have detailed events log, what is happening, even in the regular scenarios as well as when something happens. So what SIEM does, you have multiple devices, they capture the events from all the devices into a central place. Okay? So it has events as well as it has information management, which is log, basically it's log from different softwares, applications, as well as devices. So what happens when you combine things from different systems, different hardware or software, you have a global view of what is happening into the network. So rather than monitoring the actual packets, we can capture the events in the system, and based on that analysis, you can do further things. You can detect attack that is not being handled by your centralized IDP. So those kind of things can be done using the SIEM. So SIEM basically aggregates relevant data from multiple sources. It identifies deviation from the normal. So as I said, so you can also have some kind of abnormality or anomaly detection here, and it can take appropriate action. So appropriate action here means it will most likely notify the administrator. So notify him something is happening in the network that you need to look into. Okay? So these kind of things can happen. Also, we can take some actions as well if properly configured, like shutting down devices or isolated devices, those kind of things. So these are now more common in advanced hardware that we see. Web content filtering nowadays is another security service that we see. This is available in antivirus softwares as well as end routers, and I think some kind of web filtering is also available in the browsers itself nowadays. So if you are using Google Chrome, Firefox, in some cases they have filters built in. Okay? So that means they can filter out some based on URL or content, and they can give warning to the users whether this is a valid site that we can browse. So there are two levels of content filtering that we see. One is application level, one is at the network level. So application level means we look into the URL that I said, like Google Chrome or Firefox. So when you give the URL to the Google Chrome site, so they can analyze the URL based on reputation filter. I'll talk about it later. So based on some filtering methods, they can either they can allow the system or allow you to use the site, or they can block it from users. Okay? For example, if I give another example, nowadays, if you have HTTPS site, if the certificate is not valid, they block you from using that particular site. So this is kind of web content filtering that we see at the application level. On the network level, this is more for the administrator or in the network. So we filter the packets. It's not about just URLs. It's more about the content of the packet that is coming in as the user is using the internet. So in some cases, it examines the IP addresses. In some cases, if the packet content is also examined. For example, when there is HTTP packet, you can look into the packet as it is. Okay? Even for HTTPS, there is option to look into DPI or deep packet inspection. So even though we are using HTTPS, what they're saying, some of the devices that Cisco or big manufacturers have, they can actually look into the packet and I would not say they can decrypt the content, but they can take some of the signatures from there, what you're trying to do. So these are available in web content filtering. So there are several levels of filtering that we see. There is adult content, filtering for adult content, malicious content. Illegal content is nowadays a huge issue, especially in the international market. So like pirated movies, pirated softwares, whether those are coming into the network through illegal or without licenses. Those are the things are now being more into the web content filtering scenarios. This is more common service in our cases, email security. So the first one that we need is protection from spam. So spam, we have the malwares, we have attachments, all those things. So when we are using email services more and more, but also we are becoming more vulnerable as our email addresses are exposed to the internet and to the users. That means more emails are coming into us. So when you have a strong security services in place for our emails as well, that means the security service can actually filter those spam for us instead of delivering to your inbox. So web service can protect this kind of attacks. So they can look into the attachments, whether that is a malicious content, whether that's a virus or botnet. So when we do that, that means the end users will become more secure rather than they fall into those traps. So these kind of things are available. So when you have the filters, we can block the data theft. Also, we can prevent credential theft. So, for example, one of the common things that that is reported that people clicks on the URLs in the emails, which is redirected to a new browser, and that can get personal information from your site or from the users. So when you have the security in place, that even if you click on the URL, so the system will not allow you to actually go there. So it will block you from going to that particular URL or even giving you information. Okay? So the idea is, even if you are making a mistake as an end user, you can still be protected by the security system or security services. The final kind of services that can be provided in the cloud is called vulnerability management. So this is more for the management level. So this is a continuous process of looking into the system. If there is any weakness, how to improve the system, whether the firmware has been updated, or the system has been updated, how to upgrade the hardware or software. So this is continuous system of monitoring the vulnerability. So this also is different for organization to organization. So if you are thinking about your own home network, that is different from a say university which has thousands of users. But if you go into the military network, that has to be more secure. So there has to be more stronger system in place. So this basically allows you the management how to discover the weakness, how to discover whether there is any attacks into the system, and how to get reports, regular reports from the system. And from those reports, they can prioritize what to do next and implement the decisions. Okay? So as I said, this will be different from different organizations. What is their requirements, how they want to manage the vulnerability. But this kind of system can be integrated into the cloud so that it can be customized based on end user needs. Okay? That's why it can be provided into the cloud system. So this kind of system can be provided by the cloud. So that's what we're saying. This type of system can be provided to the NRAS, which is we're calling Cloud-Enabled Security Service, or CESS. And through the CESS, we can provide these security services. So the idea is similar to CESS. So it allows a provider, not for the host, it is for the provider. You're providing as an end user service like VDRAN or MyHAN. So it allows those providers to provide security services to the end users. Okay. So that's the basic idea of CESS. So because it is centralized, so we get the same benefit from the cloud. It will be cost effective because it is centralized. It will be enabled for thousands of users or all the users that is in the network. It is scalable. That means based on the user level, it can be scaled upper or lower into the network. And it can replace some of the on-premise applications. So what it means is, so you have networks and you have sub-networks under that, right? So if, say, VDRAN is providing the service, and under VDRAN there are 30, 40 universities that are getting the service. So if VDRAN is providing the service, that means those institutions now can remove those services, or they can be secure without even further investment. So those kind of savings can be done if we move the security services into central place. Okay, so that's the basic idea. So the question that we may have, why even we need CESS? So if you think about it, most of us who are using laptops, computers, or mobile phones, we have antivirus software installed into the system, right? We have some kind of host-based intrusion detection system built into the antivirus. We have application whitelisting, we have firewalls. Some of the case, I think many people uses, Microsoft has a, I think, file locking service. It's called BitLocker. So you can encrypt the whole file system that you have. Have anyone heard about TPM, Trusted Platform Module? So this is a small device, hardware device that is tamper-proof, and it is built into the motherboard, and it has a processor, and it has its own storage. So we talk about a lot, how to store data, how to encrypt data, but there is a big vulnerability you have how to store the key itself. Okay, so you are encrypting your data. How you are storing your key itself. Okay. So in many applications, the key is also stored in the hard drive. Okay. So attacker can have access to the hard drive and then retrieve the key. So the concept of TPM is that you can store the keys in there, and it is tamper-proof. The attacker will have no access there. Another thing is it has the hardware serial number generator, which is has proven better than software random number generator, which is an essential part for encryption and algorithms. It has built-in implementation of AES, RSA, the encryption algorithms. That means without even using any other software, we can use the encryption from this TPM type of device. So even though this is not very popular or used nowadays, most of the laptops, specifically if you are using a Dell or Lenovo, so there is a 90% chance that you have a TPM in your device. Okay. As far as I know, all the laptops of Dell, they have TPM, whether you want it or not. And many of the Lenovo laptops, they have the TPM built in. So another reason TPM is used is for face fingerprinting. So the idea is that if you install an operating system, so there is a fingerprint of that particular device. So imagine that you save that fingerprint. Now, if a malware is installed without you knowing it, that means that fingerprint will change. Okay? So if you match those fingerprints from your previous build and after the malware is installed, that means you can find the vulnerability. Okay? So in those cases, the TPM module are used. So there are many other applications in research. This is still going on. Sandboxing is another method that we use to identify threats. So we have all these things in place, but why do we still need this kind of SaaS system? Okay? So if I look at the real threat or the reality we have, not all end devices in the network have protection. Yes, we have protection in the device, but maybe you have hundreds of devices. Maybe one device is not protected. And that one device can infect the whole network. Okay? So that is one of the reality we have. Second threat we have is that even though we have antivirus system protections, it's not regularly updated by the end users. It may not be updated automatically or maybe for license expiration. Okay? So whenever it is not updated, that means it becomes vulnerable because we are missing the signatures, as I said before. So that means if you are not updated, that means the signature is not updated. That means if there is a newer virus, those devices is vulnerable to those viruses. Okay? So this is another scenario that we have. So no protection method is perfect. So this is an analysis from I think 2013 or 14. So the maximum, this is a rating out of 10. The maximum rating we have is 9.52 by G-data. I think many of us familiar with Kaspersky, which is 9.2. So what it says, basically, these softwares can provide us security up to 95%. So what happens with the 5%? Okay. So that means we should have another level of protection that can save us from those 5%. Okay. This is a new paradigm. I think we talked about it a little bit in the last session or in the yesterday. Wired means bring your own device. This is becoming more and more realistic. So people come in with their own smartphones, own laptops, connecting with the networks. So if you think like an application administrator or system administrator, so you can handle all your laptops, all your desktops, everything, but you cannot handle thousands of people coming in with your own device. If you think like of a university, there are hundreds of thousands of students are coming in. You cannot handle all their devices. Okay. So this makes things more challenging, and this becomes also a new area of vulnerability that we have to look into. The growing number of mobile devices, that is I think a big reality now. So everyone has smartphones, most of us, and is connected to the internet, right? We are using different types of services from the internet. So that means those devices also need to be secured. Not only the laptops, end devices or routers. So these mobile devices can also be used for attacking the network. Okay. So this is the reality that we have. We can also infect it via email. So the idea of CESS is that we can move the security services centrally at a location that is providing the service. So it's not saying that we have to remove the end user security mechanism. It has to be there. But this is like another layer of security at the top. So it's like, added security at your main entrance when all the packets is coming in and going through. We still have security. We need to have security at the end level as well. Okay. So when you move this into the cloud, that means by default we can provide security to the entity that is connected to this cloud, to the users that is also connected to this cloud. Okay. So that is the big benefit that we have when we can use centralized security services. So the proposal that we have in DCNDS project, in this particular project, so we are setting up CESS and BDDEN. So the idea is when you set up CESS service in BDDEN, so BDDEN has I think 30 plus universities nowadays connected. So when we have the service installed in BDDEN, by default we can secure thousands of students and teachers and other members that is working or using the services through BDDEN. Okay? So that is the basic idea. So by installing BDDEN, we are providing services by default to all the university that is connected. So what we are going to do here, we're going to deploy a proof of concept CESS in the BDDEN cloud to secure the web traffic. That's the first target. So for the participating institutions. So if what the plan is, existing web traffic will be proxied to through this CESS system. So it's not so that we can monitor and we can filter out the system data as we need. And there will be web security policies that will be applied to the BDDEN as well as the institution as well. So whatever policies that is defined for the institution, that can be applied to each institution as necessary. So all the inbound and outbound network traffic will be controlled by the BDDEN. So what CESS will ensure is that the security policies can be managed centrally, so that at the university level there is minimal interaction or minimal management is necessary at the university level, and it will be applied for all the institutions that is participating in the BDDEN. We also have permission and plan to collect the metadata, so that the traffic that is going through BDDEN from different users or different universities. So we look into the header of the packets and we'll find out different statistics and we'll some kind of analysis based on those data. And of course this data will be anonymized so that there is no trace of identification, and later on this data will be shared among the stakeholders for further research if you want to do it. So in terms of implementation, how we are going to implement it. So you cannot develop it on our own. So there are technologies already available so that we can provide this kind of services through a provider. So these are the top solutions that we have: Cisco Web Security Appliance, InstaSafe Security as a Service solution, Smoothwall has unified threat management, ForcePoint also have cloud and email security, and Zscaler solution also have their own solutions. So what basically what we'll be using the Cisco security appliance. The reason being is
as I understood from yesterday's presentation that we didn't have OpenStack-based cloud services. So OpenStack. So OpenStack, does it have built-in security service tools?
no.
No, it doesn't. Because I
So-
know it has many modules.
So-
programming.
Are you familiar with VMware?
Yes, virtual machines.
Right.
Yes.
So OpenStack is similar to that. So the idea of OpenStack is they said metal as a service. So the idea is you can have your own metal, like regular machine, regular PCs, servers, and on top of that you can provision like virtualization. And they have like softwares to provide the network services. That's how you manage your system. But this is like the system is only for particularly for virtual machine management, right? So on top of that, what Fiverr is doing, they are using that infrastructure to have their own the Fiverr lab. But basically, you can install Fiverr lab in your own machine. You don't have to have OpenStack. If you have a regular server, you can actually install Fiverr lab. So there is like no dependency on the OpenStack itself. Also in this project. So I think in this project we are using Fiverr for data analysis. So as I said, we are going to capture metadata. So the idea is we can use the Fiverr functionality to analyze those huge amount of data for the analysis. So one idea is for botnet, and we can also try our own algorithms for malwares and antivirus. Okay, so we are going to, as I said, we're going to use Cisco mainly because BDDAC has already have the infrastructure for Cisco, and actually this week we got finally we got the packages from the TAIG for the procurement process. So we are implementing the CESS as a case study at BDDAC. So we will be using the Cisco. So let me just give you a highlight what Cisco will be doing for us in this solution. So Cisco has brought threat intelligence. That means they have, Cisco is a big company. They have customers all over the world. So they have a central database where they collect data from all the devices all over the world. So they have the threat analysis data from the global point of view. They have multiple layers of defenses, web security, email security, malware protection, threat detection, and data loss prevention. These are all built into the security services that will be installing in the BDDAC. So if I look into the key features, there is 3 types of protection. One is before the attack, one is during the attack, when the attack actually happens, if that happens, and what happens after there is an attack. Okay. So I'll talk about a little more later on. So it has built-in monitoring system so that you can monitor the whole thing that is in your network, and how you can take actions quickly when something happens. So the deployment options is flexible. We can deploy it on a particular appliance, we can deploy it on a virtual machine, or even branch router. So I think for the BDDAC, we'll be using a branch router for the installation. And it's scalable. So nowadays it is designed for all the current users of BDDAC. So if the user level is increased, we can also increase the capacity as well. So Other features include automatic traffic analysis, both inbound and outbound, that is going in and coming out. It scans traffics in real time for both known and new malware. So the note here is that all the web traffic is not actually known, because it's not feasible, because I think BDN now has 30 Gbps of traffic going on in the peak, or even more than that. So it's not feasible to analyze all those stuff. So they have mechanism to first level of filtering. If they have something suspicious, they move into the second level. They have dynamic reputation filters, behavior-based analysis of content. And this is important, identification of zero-day attacks. So zero-day attacks basically means very recent viruses that is launched into the system, into the global networks. So how fast you can detect and how fast you can make yourself secure from those things. So the benefit of Cisco is that because they have so many installations, so they can detect in different locations, and they can push those information to all the installation very quickly. So even if an attack is detected, like in say Europe, they can notify the systems all over the world, and those will be detected. So these are more for like administrators. We have application visibility and control, see what is happening into the network, create more granular level policies if you want. So we can create policies that we want users to access only this kind of sites, some other sites can be blocked from the system. Okay? For example, if the policy permits, we can block all the Tor, privacy, onion router traffic. We can block the BitTorrent traffic, the peer-to-peer. So those are the things that can be enforced. Even if you sometimes we see requests from the government, right? Like Facebook should be blocked, YouTube should be blocked. So those kind of things can be done if you want to in this kind of system. So, and also this is without slowing the adding additional manpower based on their usual manpower we can do. So let me talk about a little bit about the security framework of before, during, and after an attack. So there are certain things that we need to do. So before an attack, if you think about it, we need to continuously monitor the system. We need to upgrade our system. We have to discover new things that is happening, new threats that is happening in our network or in global networks. Then, based on those information, we have to harden the system so that we are not attacked by those new threats that are happening. Okay? So this is one of the things that we need to do before the attack happens. And there's another thing is during the attack. So the attack has already been launched, and during that we have to identify, we have to detect that we are being attacked. And so the next step, when you detect that we are being attacked, the next thing is you have to block those attacks, and you have to defend so that you are not vulnerable more. So you already have some damages, but you have to stop the attack so that the damage is not more precarious into the system. And after the attack has happened, this is more important. So we have to identify the scope of the attack. How many devices have been vulnerable to the attack? How many are affected? How to isolate those things? How to contain those things so that new devices are not infected? And how to remediate? How to recover those devices? How to make the system more secure after that? So these things needs to be taken care of when you propose a security system. So before that, so the CESS will detect and correlate the threats in real time. So as I said, they have a global database of attacks that is updating continuously. So they claim the information is refreshed every 3 to 5 minutes globally. So that means in whatever the attack happens, the system will be updated in 5 minutes at the max. So that is a very good thing. So they are getting information from firewalls, IPS, web, email, VPN. From all those devices globally, they are capturing the data. And then globally, they are pushing those data, updating those data in every system. Web reputation filter is an integrated part nowadays for web users. So the idea is we have to, for unknown URLs, we have to analyze and categorize. So there are some known URLs, right? Like google.com, facebook.com, these are known URLs that you know. Okay. But when you see something unknown, when that comes through advertising, comes through scam, so then we have to be really careful. Okay? So these kind of things will be done by the central system. So when you see a new request, new IP coming in, how to filter those URLs, how to categorize, how to find out the reputation of those URLs, and if we can block those URLs from the end user so that users cannot use those URLs. And for valid URLs, we can pass through to the user so that is active or that is a valid URL. So in Cisco, they claim there are 200 different traffic and network-based parameters. So using these parameters, they actually give an index or metric that is the reputation metric of a particular website. If I give an example, I think we have, so this is an example of reputation filter. So based on, there's some example of the metrics we have: domain owner, hosting server, time the website was created, what is the type of this site, what type of content this particular website is hosting. So based on this, a particular reputation filter can be created. So here is an example of a particular reputation mechanism. So the idea here is that the reputation can be between -10 to +10. So this is not like a global standard. So it will vary from device to device, in application to application. So the idea is if the reputation is very low, we'll give it a negative mark. So if you see like this one, so the IP address controlled by a spam house or a known open proxy generating massive volume of complaints and spam traps, almost guaranteed to be spam. So complaints means users sometimes complain this is spam, right? So we have in your, if you are using Gmail or Yahoo, we can report any email as a spam, right? So there is a global database that captures the data from different spams, and they can track who actually sent this spam all over the world. So based on this, dynamically you can identify which IP addresses are the source of this kind of spam, what IP addresses are hosting illegal things. So based on different criteria, we can find a reputation score. So the less the reputation score, that means this is likely to be more dangerous to the end users. Okay. If you go to the right, so if you look this, like I think +2, some spending history, low and moderate complaint. So this is like a newer company, but not too much spam. So one thing I think I should mention, in all cases, the spamming doesn't mean that is a attacking site or server. Sometimes due to the configuration. So for example, say you have your own server. You're hosting maybe say your university website. So maybe for configuration, it can be part of spamming. It doesn't mean that you are spamming. It means the attacker is using the server for spamming. Okay. So that means based on the reputation will get low. So as long as you take remedial measures that spamming doesn't happen into the server, the reputation score should go up. Okay. So in the last, the known enterprise who has a long history, has certifications, so they're likely to have higher reputation score. So what basically it means when you assign a score,